Okay, so now that we've discussed the different types of chemical bonds, we want to focus for a while on covalent bonds. So ultimately we want to draw the larger configuration for covalent molecules. But before we can draw out covalently bonded molecules, there's a couple of definitions, type things we need to get out of the way. So I think most of these you're probably familiar with. So bond length is the average distance between two nuclei. So bond length, we will discuss a little bit later how it's determined. Bond energy is the amount of energy required to break a bond. And you'll see that bond energy and bond length are inversely proportional. So that means as bond length gets larger, so as a bond gets longer, so as atoms get further apart, the amount of energy required to break that bond lessens. Okay, so those are inversely proportional, and we'll use that concept quite a bit in the coming videos. A molecule is a group of atoms bonded together, so typically we refer to a molecule as a covalent molecule, so something held together by covalent bonds. So a more specific way to say that is a molecular compound. So a molecular compound is a compound held together only by covalent bonds. So that's what we'll discuss drawing in the coming days. And then a chemical formula are just the symbols and numbers of atoms present in a molecule. So something like H2O. So for water, H2O is the chemical formula. It has hydrogen and oxygen present. There are 2 hydrogens and 1 oxygen. Okay. So we're going to discuss these terms at length in the coming videos. But I just want to go ahead and throw them out to you here, let you have the definitions of them, so you can kind of have those in the back of your mind. That way, when we discuss them at length later on in the coming videos and chapters, you'll have the basic background idea of what these terms mean.